Hi, this is an explanation on how to calculate elasticity. We are dealing with a situation where we have 2 points and we want to calculate the elasticity between those 2 points. The best way to explain elasticity calculation is to actually go ahead and do a calculation, and so we have an example of 2 points. We'll call one point A, the other point B. And so for point A, we know that price of the product is 10. The corresponding quantity of the product is 30. For scenario B, for point B, we have the price being 14 and the corresponding quantity is 20. Notice that when the price goes up, quantity goes down, or when the price goes down, quantity goes up. So this is a representation of the demand side of the market. So this is an example of elasticity of demand with respect to the product's own price. We could certainly create a slightly different example where we're looking at the price of some related good changing and the product's demand changing. That would be cross-price elasticity. Or we could have looked at income levels changing and corresponding changes in quantity. That would be an example of income elasticity calculation. We could move to the supply side and talk about price changes or other changes and quantity supplied changing. So that would be an example of elasticity of supply with respect to whatever the triggering variable is. So our example here again is elasticity of demand, so quantity demanded changing with respect to a change in price. Okay, so the best way to approach the calculation is to think of the various steps that would build up to the elasticity number. Step 0, I'll call, is to simply know or remember the definition of elasticity. That's something that we just have to know. That's what we are going to use or apply in calculating the elasticity. So step 0, remember the definition. Of elasticity, and in this case, we would be applying it to demand elasticity with respect to price. So elasticity of demand with respect to price would be defined as the percentage change in the quantity is demanded divided by the percentage change in the price. Okay. And so it helps us to recognize that here's one thing, here's another thing, and here's the remaining thing. And if you look at it that way, you would recognize that if we can calculate, or if we have information on this, or if we have information on this or can calculate this, then with these two pieces of information we can calculate elasticity, and that's what we are going to be doing in this example. If alternatively we had information on, let's say, percentage change in price, or we could calculate percentage change in price with given information, and we knew the elasticity, then we could use this formula to figure out what must have been the percentage change in quantity. Similarly, if we had information on the percentage change in quantity and we had information on the elasticity, then we could use those two pieces of information to figure out what must have been the percentage change in price. So these are the different permutations, different ways in which we can use this definition, apply the definition to calculate the changes in a given scenario. Okay, so that's what we are trying to calculate. Step 1 is to go ahead and calculate one of these percentage changes using the information that we have. So let's look at, let's say, the percentage change in price. Here we have these two prices and we are trying to calculate the percentage change. Note that we did not specify in this example which one was the beginning price and which one was the later price. When we don't know which is the specific beginning point and which is the specific end point, we have to treat both of them as potentially the initial point. So we would have to use the average between the 2 points, the midpoint, as the initial point. Okay? When we have a different type of example where it is specified exactly, very clearly, which is the starting point and which is the end point, then the starting point is the initial point in terms of calculating a percentage change. In this example, we don't have that specification, so we are going to be using the middle point between the two prices as the average initial point. So percentage change, and I'll use the delta sign for change in price, is equal to the change that we see between the two prices divided by the midpoint price. The change between the two prices, let's say between 10 and 14, here we have the difference is 4. And the midpoint between these two prices would be the average of 10 and 14, the middle point between 10 and 14. So you could just cross-check by taking the sum of the two numbers and dividing by 2. And so that would give us 4 divided by 12. Okay. Or 1 over 3. I'll leave this as 4 over 12 and move on to step number 3. So this is what we have for the percentage change in price. So we have that. Now we will do that as step 2. Where we are now looking at percentage change in quantity, and the percentage change in quantity coming from these two numbers would be the change in quantity divided by, again, since we don't have either one as specified to be clearly the initial point, we have to treat both of them as potential initial point. So we'll just take the average of the two. That's the midpoint approach, using the midpoint Q. So this would be the difference is, well, we are going to recognize that when we move from 10 to 14 and 14 to 10, when we were looking at the difference in price, we were looking at a positive change, of 4, but then here we should be looking at the negative reaction to it, so negative 10. The negative sign is what we're referring to right now, capturing the law of demand, capturing that price and quantity are moving in opposite directions. So that's what the significance of the negative sign is. So negative 10 divided by the middle point of those 2 points, 30 and 20 divided by 2, which gives us negative 10 over 25. Okay. So that's the percentage change in Q, and we already had the percentage change in price from before. So step 3 is to use these two results and get the elasticity. So step 3 is to plug in the results into the definition, the formulation of elasticity. So elasticity of demand with respect to price is the percentage change in price, percentage change in quantity, which we calculate as negative 10 over 25 divided by the percentage change in price, which we had calculated as 4 divided by midpoint 12. And so you just carry out the arithmetic here and you would get the elasticity. I'll go ahead and do that with simplification before I get to the calculator. So negative 10 over 25, and I'll flip this into a multiplication, taking the reciprocal of that. And so if you work that out, you'll get negative 120 over 100. So that's simply negative 1.2. That's the elasticity calculation. Notice the negative sign is simply capturing that price and quantity are moving in opposite directions. It's capturing the law of demand. So that's the significance of the negative sign. The significance of the number, the scalar, the magnitude being 1.2 is that it's greater than 1. So it's capturing a price elastic demand. So quantity is responding more than proportionally compared to the initial price change. So it's like a large response that we are seeing. If the number were below 1 with a negative sign in the front, then that would have said that quantity response would have been proportionally smaller compared to the initial price change. If the number is exactly 1, then that captures unitary elasticity, where the price movement and the quantity movement are proportional. Again, as we said before, these examples could be altered to have related products pricing. That's how we would calculate cross-price elasticity. And with cross-price elasticity, the sign matters greatly, because positive sign versus negative sign would allow us to distinguish between substitutes versus complements. If we had income as the triggering variable, then corresponding quantity response could allow us to calculate income elasticity. Again, the sign would become very important, as well as the magnitude. If the sign of income elasticity turns out to be negative, then that means that quantity is moving in the opposite direction compared to the income change, and that would capture inferior goods, where the income-based response is negative. If the sign is positive, that would be the more typical scenario, and we call those goods normal goods, as long as the income elasticity is positive. And within normal goods, if the magnitude were below 1, in other words, if the income elasticity is between 0 and 1, then that tells us that it's a basic normal good, a necessity. If the income elasticity is greater than 1, then that shows large responsiveness, large sensitivity to income changes, and that would be capturing luxury goods. So these are the various categories, interpretations, or labels that we use for elasticities on the demand side. And the calculation steps are these, starting with the definition and then going step by step. So as long as we go step by step, it's very easy to get the right result. And whenever we need to use calculators, that's totally great. And if you're using calculators and using decimal points, just make sure that you don't round too much too early, because then that could lead to rounding errors. It's better to keep fractions and or to maintain a higher degree of decimal places in the calculation. That's elasticity.